Hello class, let's take a look at example 5. And the first step on this example is to identify what type of test we're actually performing. Now, this is basically given with the claim, and they're telling us to use in this case, the level of significance, it's actually going to represent the values of alpha. So alpha in this case is 0.05. So the level of the test is basically 0.95. So in this test, we're going to be carrying about a 5% error in the calculations. Now for the type of test, do we have the values of sigma? And in this case, it doesn't look like we have sigma. Let's go over the information that it's given. So they mentioned the random sample, that's going to be n. And then from this random sample, you technically have that they can map with the following values in terms of measurement. So in this case, we don't have sigma. The type of test that we're going to be performing, it's going to be a t-test. And then more importantly, they're asking for the p-value. So in this case, we're going to actually do the shortcut. Now, let me guide you through the shortcut. So you're still going to start with all the values of the sample. So in this case, from the sample, we technically have that the values of n is equal to 50. And then from this sample, for the blood cell count, you're going to have that the mean is equal to 5.23. And then we have a standard deviation of 0.54. So this is the particular sample that we're actually taking a look at. And what they're asking us to do is to look at the claim, and the claim is that the mean is less than 5.4. So in this case, what we're actually looking at is if there is enough statistical evidence that this sample comes from a mean that has that value. So in terms of the p-value approach, you're still going to have to show the following. In this case, you're still going to start with the claim. And the claim is that the mean is less than the values of 5.4. And well, you're still going to have HO and HA, or H1. And in this scenario, let me write them here. The values of HO is that mu is equal to 5.4. And the values of HA is that mu is less than the values of 5.4. Now, I'm following that based on what it's actually given for the claim. So in this case, the mean is less than 5.4. The actual setup of the hypotheses are actually on page 1. So let me guide you through that. In page 1, you're looking at the following scenario. And the scenario happens to be that the claim is on a less than statement. So therefore, this is the particular scenario that we're looking at. So we're simply looking at this particular scenario. Let me remove that. Or a left-tail test. But because they mention an actual claim that less than, that's going to be the scenario. Also, this is going to be the actual test statistic because we technically are not given any information on sigma. So let me go back to the problem. As we're continuing with the p-value, you still have to show the test statistic. Now, the formula for the test statistic, it's t is equal to x bar minus the values of mean divided by the standard deviation over the square root of n. Now, since they want the p-value, it's just best to run all the values in the calculator. And let me show you where you're going to be retrieving each one of these. So you're looking at stats and then all the way to test. And since we don't have the value of sigma, this is going to be a number 2 t-test. And then make sure that you input all the proper information. Mu refers to the actual value of the mean. So this is the claim that they're actually providing. For us is the 5.4. The mean of the sample is 5.23. The standard deviation is 0.54. And then the most important part of this test is part of the claim. The claim is less than, so you have to make sure you're highlighting the one in between where it says less than mu of 0. And then please take a second and run it. The calculator will give you automatically the test statistic. In this case, our test statistic, it's just going to be negative 2.23, rounding to 2 decimal places. So approximately negative 2.23. The p-value given in the test, it's actually 0.0153. So 0.0153. If you round to 2 decimal places, 0.02. Now, at this point, we're almost done. We just have to look at the main condition that's on page number 1 for the p-value. And in this case, we're looking at this condition. Now, you're simply comparing the p-value to the values of alpha, and if it happens to be less than the p-value less than or equal to alpha, reject HO. If it's greater, fail to reject HO. So for this one, let's take a look at what value of alpha is given. And since technically alpha, it's the level of significance in the wording of the problem, this one happens to be less than, let me write it with the same color. So less than 0.05, which is equal to alpha. So for our main conclusion, and I'm just going to go back to the original, since you're looking at this scenario where the p-value is less than or equal to alpha, you automatically reject HO, and then you write it up in the following format. So you would simply say, well, reject HO with alpha is equal to 0.05, C is equal to, in this case, 0.85, and you can simply say because the p-value of the test, it's approximately 0.0153, which is less than 0.05, which is equal to the values of alpha. This is the minimum that you're actually rewriting. You're always stating if you reject or fail to reject, and then why this conclusion is being done. Now, let's talk about what it actually means. The test is based on rejecting HO. And in this case, if you reject HO, that's part of the hypothesis. That means that there's not enough evidence to conclude that the sample is from a mean that happens to be equal to 5.4. So rejecting HO, that means that the most likely scenario is that this actual sample, it's coming from a population whose the mean is less than 5.4 with a 5% approximate error. For this one, this is just the minimum that you need. If they were to ask for the proper, the proper wording, you can reference example 2 on that one.